My name is Nandan Nampally. I run marketing and strategy for primarily the CPU portion of ARM, but obviously all the solutions that we need to put together are more than just CPU. And what I'll focus on today is walking through one, what does IoT mean? What does it mean to you? And what are we doing to enable what we feel is a pretty burgeoning, what should I call it, market in this space. So let's start with the question. What does IoT mean to you? It could be, San Diego, for example, has smart lighting. They started putting actually controllers in wirelessly connected lamps. And so they believe they can get a pretty large saving on both the control of the lamps, understanding when things are out. So it's a quality of service as well as a power play, or for in terms of cost. You could talk about cities actually using automotive sensors to help traffic congestion. You could think of medical situations where you have doctors remotely monitoring your health, or your personal trainer actually knowing how you're doing with your regimen, even though you're in Korea. So effectively, it's a pretty wide set of things that constitute IoT. Effectively, what we're saying, though, is there's a lot of things, and these number of things keep increasing. So speaking of a couple of sets of things, if you say, that are increasing, you think about consumer and health growing from just under 4 billion units today to 10 plus billion. You look at smart cities, again, going threefold, automotive and transport. Literally all of these verticals, if you will, are expected to grow 30 to 40% in terms of units year over year. So that is a lot of things, right? But one thing I think you need to understand about that is it's not the same. So effectively, if you think of every tree as a vertical, a tree by itself does not a business make. You are going to have lots of these trees, but they only need to be tied together by an ecosystem that works. So while you could have an IoT solution that works in medical, it may be very specialized, but it may not work in other segments. And let's say a smart city picks up a set of solutions. Great, they have used a specialized solution, come to it. But when they start bringing in new components from other verticals, they need to start working together. So you can't really design a specialized solution that is devoid of its need to work closer with the ecosystem. Right? And for the ecosystem, we, for example, ARM is 25 years old as of November last year. We have focused on building primarily that. We sell IP, right? And silicon's not what we sell. We enable people to sell silicon. But some of the first investments ARM made, apart from the IP itself, were in the tools, in the compilers, and in the components that go around the CPU, for example, to get these things to market, because finally these are not standard parts or just a processor by itself. These are systems on chip, and all of those things need to work together. And so as you've kind of seen ARM invest in the ecosystem, it's gone from tools to software. We've been helping with partners building modules and gateways. And now effectively we are working both from an IP side, on a system side, and an ecosystem side on cloud. So from the data center or networking angle, ARM has products in it. Obviously the next step beyond that is working with the operators to make sure that what they need out of the OEMs, and thereby the module and gateway providers, and thereby the silicon providers, is something that can help make the ecosystem bigger. And then finally, the ones that really use it are the end users, of course. So we need to make sure that the ecosystem actually works for all and up and down through the chain. Okay? So effectively what we need for IoT is literally everything. You get everything from sensors to home gateways to smartphones. Your smartphone is a very legitimate IoT device. You've got white goods in the home. You've got automobiles, and then of course the data center. Effectively, IoT is not really a device. It's not even a segment. It's effectively delivering service across the cloud or other to a connected device. So the main things are a connected device that can actually consume or, in fact, deliver a service. And what that means is when you're talking about something all the way up in the cloud, all the way down to a remote sensor in a field, you're not going to have the same product go everywhere, right? And the ARM architecture has been a very strong baseline, but targeting very, very different endpoints. So the first, obviously at the very low end, is the Cortex-M product line, which is targeted at very small footprint, low power microcontrollers, those that could last on a CR232 battery for a year, a couple of years. And obviously the needs for that are different, right? When you look at the things like industrial components, you look at cars, you need much more predictable real-time performance, a greater focus on safety. That's where the Cortex-R line of products comes in. And then when you're running things like Linux, all the way from your smartwatch potentially, all the way up to the cloud, you need products that have memory management units and can deliver kind of the experience you expect with larger, richer operating systems, Linux, Android, and the like. And those are the domain of the Cortex A-class products, right? So effectively, one size does not fit all, and we are providing components even within these various profiles that hit very, very different points. And I wanted to touch on a few of those solutions that actually are helping the IoT world today. So speaking of those, at the beginning of this year, we launched a product called the Cortex A32, which is an ARM version 8 architecture product that is targeted at smarter embedded devices. And these could use your home gateways, you could use them for wearables, they use for single board computers, things that actually need a much stronger user interface, need to run a full user experience that you'd expect on something like Linux or Android. And actually being able to do those kinds of devices running 500 megahertz, fully capable, under 20 milliwatts, really changes the game of what you could do with these kinds of end devices. Now, you add on to it an inbuilt capability to do more advanced encryption. That again sets the base for what a lot of these IoT devices need, which is really the ability to secure, especially how personal they get, the content, the data, and the transactions that go across. And obviously, with anything that you need in the embedded space, these products have to be very configurable and scalable, because that's what you see, very differentiated solutions everywhere. Okay. Now, moving to an even larger potential volume opportunity. These are things that you'd say are in your retail smart price tags, for example, or smart lighting. You look at a lot of the home automation aspects of it, smart white goods. These need not just standard microcontrollers, which they're doing today, but an expansion for it beyond it, where you may add a different sensing capability, a different analog capability to it. And these are actually bringing together a lot of mixed signal and sensor capability in those solutions. And this is where we feel there's a lot of innovation, and in fact the level of interest we have in that space is actually very exciting. You see startups getting there, you see a lot of the OEMs and device makers getting there. They already have solutions today, they want to specialize them, they want to actually grow those for volume, and that naturally means, how do I get into this market easier, faster, and get a kind of a proven solution faster as well. Now, as a baseline for that, even the Cortex M Line, which I said was the small end of the stick, has actually the largest volume. The Cortex M's have shipped nearly 19 billion units today, and it's a very, very wide range of products. The Cortex M0, for example, even in 40 nanometer, if you put it on a human hair, you'd still have room to spare in the cross-section of it. All the way up to the Cortex M7, which today can do a lot more in terms of intelligent drones, for example, or smart audio, which effectively allows you to do a lot more DSP real-time performance. So a pretty wide range, and again, you can tune it to fit your specific requirements, right? But great, we have a product line. How do we actually get it to market? So last year, ARM put up a program called Design Start. And what that does is it gives you access to the Cortex M0, which is the small footprint product, for free. You download it, you register, you download it, you can play with it, you can actually start building designs with it. And you're going through the life cycle of a startup, right? Okay, you've played with it, now I want to prove it on show, go get my funding. We have a low-cost FPGA prototyping solution where you put in the bit stream, put your logic around it, do a proof of concept, show that it works, get your funding. And if you want to go to production, again, there's a fast path to production. It's a $40,000 license that includes not just the M0 part, but the system kit that goes around it, tooling, and also kind of support. Right, a very good place to start. Get started. In fact, we've had people who've taken the system design kit and actually gone to tape out in less than 4 months. Right, so a very easy way to start, especially for somebody that's startup paced. Well, we are seeing the kind of proof in the pudding, so to speak. Obviously, the smart goods were a natural place where we saw a lot of interest, but those types of designs are now also being used to go into more rad-hard conditions, let's say for space exploration type programs. A lot of space initiatives today. Then, of course, IoT endpoints, natural ones, and cameras is a random example, but you can actually use a product that is designed for one and move it to the other as long as you know what you're tuning for. Right? So we are beginning to see that actually spur more innovation because people can start using these products in a broader sense. And what we announced today was a broadening of that partnership a little bit further. You have obviously IP coming from both ARM and its partnership. Today we launched effectively EDA tooling access and hosted tooling access with Cadence and Mentor Graphics. And the third component is really the know-how. ARM obviously has worked with our designs and can help people get to market, but we may not have the same reach as a lot of the design houses have. And so we're working on both auditing the capabilities of the design houses and helping partners that can deliver those capabilities through this ARM-approved partnership program. Okay? So effectively, you look at it, there's every step of the way, you have something to help you actually get to market. Now, speaking of the entire IoT subsystem, the primary thing that you see in an IoT endpoint is, one, it communicates, right? And ARM, in fact, put together a product called Cordio, which was also acquired that's available, does Bluetooth, Bluetooth LE, and in fact some more. You have the computation, which of course CPUs do, and you do. And the connectivity, the piece that we talked about, right? So, and the sensing piece is the final piece, which is where a lot of the innovation comes in, and that's where the value add is. Sensing, acceleration, and then connectivity. So effectively, you can get these products from ARM, as well as a large part from the ecosystem, not just Cadence, but beyond that, and put it together into a very easy to start solution for it. Okay. When you put it together, you have what we think is going to be effectively the fabric of our lives going forward. We actually had at our conference last year demonstrations of a lot more actually health monitoring and actually exercise dynamics monitoring equipment. And when you start thinking about it, you could effectively have a chip sewn into your actual T-shirt and literally in the fabric, and people can potentially snoop into it. You realize that IoT is good, but you need to secure it, right? And securing IoT, non-trivial problem. We'll start on the components first. So what you effectively need to do is to secure the device first, right? You can get it to be able to have its own identity and also a root of trust, ability to detect when it's being fooled with, tampered. Then you need a communication to the source effectively, either likely to the cloud, that is protected and authenticatable. And then of course you've got the third part, which is the cloud itself, or the lifecycle management or device management through the secure or trusted source. Right? So you need to cover not just the endpoint, but the path to the management, and then of course the management itself. And to that, ARM has worked on technologies for a while. Trustzone is a technology we introduced nearly 12 years ago, which you can see in a lot of smartphones now. It has been used for mobile payment in terms of content protection, digital media, and of course now payment systems. And this idea is simple. You have to put the root of trust in hardware. It can be still very lightweight in terms of the hardware, and then you have a software set of APIs that allow at least the broader ecosystem to design to. But now you think about IoT, and you think about big data, everybody's connecting data. Your big data is only as secure as your little data. You need to be now able to take these security principles and put them down into components that are less than $1, right? And as our CTO tends to say, effectively, you have to be able to enable people with no security experience to be able to design secure systems with it, right? We're not going to solve the entire problem. We're trying to solve our portion of that problem. And to that, we last year introduced a new architecture called the ARM v8M, which introduces the Trustzone concepts for the very low-cost microcontrollers. And the idea is to separate the data, the hardware, and effectively the software access from the secure side to the non-secure side. And the other piece is we've effectively added instructions in it to help with it, give a simple API around it. But again, you don't need a specialized, even a small hypervisor for it. So literally you can think about transactions going from the hardware to the software side in like tens of cycles, right? Which is really important in the microcontroller world because interrupt response is critical. Now, if you put this in place, and you'll see more announcements later in the year, you start seeing not just the protection of critical assets and hardware, but also people actually value the firmware they put on the device. And you could take the firmware out, put it on some other controller, and you've literally taken a lot of value out of it. So you can protect that. You can use this as a route for actually doing remote firmware updates. And more importantly, once it's in the field, you can either make it really secure and break the whole device so it's unbreakable at that point, well, or close to. But also with secure debug, you can actually use that in the field. So there are mechanisms thereby provided to make these usable even after the devices are shipped. Okay. So effectively, our platform for secure ID, naturally there's hardware in there, the MCU and the CortexM products in there. There is secure storage and crypto or true random number generation IP that ARM has provided through a company we acquired about a year or so ago called Sansa. Similarly, that goes into the security cycle for firmware as well. You take that up one level, you've got the secure connectivity piece, and again, this is very low power communications as well as further up on Wi-Fi side. And then you've got the secure communications layer, the TLS layer, that goes all the way to the cloud, right? So you've secured the device, secured the stack underneath it, secured the communication, and now you can do secure provisioning and full lifecycle management from the cloud. Now, having done security, the other key thing that you come about, especially as these devices become daily use devices, and your car is an easy example, safety becomes critical. And while, like most times, new technologies come in and they are used on an enthusiast basis, as they become standard, you need to start complying with safety, right? So while you have your driver assistance systems, adaptive driver or advanced driver assistance systems today, more on a play basis, going forward, they will have to be certified for being safe, right? Same thing with the cockpit, same thing with the V2X, as they say, vehicle to anything communication, and then of course smart body apps, etc. And what that basically means is throughout the design, you need to do requirements capture, you need to manage it through the process, you need to be able to provide documentation and certification to get through the various critical levels for certification. And ARM's been investing in it throughout, and it's not just for automotive today, right? So industrial applications, naturally, as you start looking at drones, or robotics equipment, you'll start going to have safety requirements for that. And soon it starts getting into home automation. We expect that to start getting into kind of the day-to-day life. And what we are doing now, or have been doing for the past year or so, is delivering these product packages, which basically means we've been last 3 to 4 years been investing in the process to get our product development verification processes there to be able to help it certify. Okay, now we have put it all together. We believe that there are many axes of innovation for IoT. Obviously the little data and the sensors coming into it, the connectivity and the low power connectivity around it, naturally the applications that are built on it, and of course within the cloud that is going to deliver a lot of these services. So multiple axes, all of them having their own real, what should I say, disruptive solutions, innovative disruptive solutions. And so for ARM, we intend to be the foundation for the successful IoT solutions, as we said, from endpoint all the way to the connected cloud. So we have the ecosystem for it. We have the security technology which founds the base for it. We are constantly innovating when it comes to energy efficiency, performance per milliwatt, performance per watt, which is our calling card. And then, of course, designing those products for safety. So with that, I'll kind of talk a little bit about what we're going to set up in the next two I guess sessions. We have a session on how can the startups being built for next great IoT chip, which will kick off just as soon as I finish, so I'll keep this short. We have a similar one tomorrow with different players except me. I'll come back tomorrow. And then all I wanted to say was explore the ARM IP on ChipEstimate. And of course, we'd like you to plan your next chip with our IP in it. And of course, if you need to contact me or talk to me, I'm around after this. Thanks.